Continuums of CoGNETs turns a group of everyday devices into a single collaborative IoT-to-cloud computer, right where the end user is. Game theory decides, autonomously, who joins, who leads and who computes, and it runs distributed AI and cybersecurity together in real time. The system is at technology readiness level 5, validated in a relevant environment, and everything you see next is running live. Here is the running system. Each device is a node in the swarm. Every round they bid for resources, the game re-elects the leader and the workers, and the audit console traces every call as it happens. The first contribution is autonomous decision-making, driven by games. There is no central controller. Each device decides for itself, through a game-theoretic auction, whether to join, what to share, and how much. The system settles into a Nash equilibrium that allocates resources fairly and efficiently. 3 roles are elected among the devices, never assigned by the laptop. The leader, algorithm 18, is the one active brain, it runs the game and the elections and serves all rights. The replica, algorithm 29, is a hot standby mirroring the leader's state, so it promotes in milliseconds. And the aggregator, a separate election, algorithm 23, runs federated averaging and owns the global model. Every device carries the full software stack. Exactly one is the active leader, one is the replica hot standby, and the rest are idle but ready. When the leader fails, the game re-elects instantly, the replica that was already mirroring promotes to active, and a fresh replica is elected, without ever touching the laptop. Here are the elected roles live, one device is the leader, starred, and it drives the game while the aggregator holds the global model. Now we compromise the leader. Its security collapses, and because the election is security dominant, the game instantly re-elects a new leader on a healthy device. The star moves across, and the swarm never loses its head. The learned model itself lives in the model store. After each round the aggregator runs federated averaging and writes the new global weights there, as content-addressed blobs, kept off the broker and on the swarm in 2 copies, on the aggregator and the replica, so a single failure never loses the model. Every device pulls the latest model for the next round, and the model never leaves the swarm. Second, it is lightweight, by a fully end-to-end mathematical, analytical design. Every stage is solved in closed form or with provably convergent dynamics, Nash bargaining for the prices, proportional Fair-Kelly for the shares, best response equilibria, and stable Gale-Shapley matching for the tasks. No brute force search, no simulation, no black box machine learning. Each device exchanges only tiny scalar bids, about 20 microseconds per round, so it runs on any end-user device, from a smartwatch or phone to a laptop or tablet, even a Raspberry Pi. Third, devices can join and leave at any time, with no warning. A new device is admitted into the very next round, and if a leader or an aggregator disappears, its role is re-elected instantly onto a healthy device, so the global model and the services never stop. Watch the swarm scale in real time. It starts at 3 real devices, and as new nodes join, each is admitted by the same game into the very next round and bids at once. It grows from 3 to 8 and on to 20 devices, node by node, and the game re-elects the leader, replica, and aggregator across the larger swarm as it grows. It scales smoothly from a handful of devices to dozens, with no central coordinator. Now the system under harsh conditions, the kind you meet in the real world, where devices genuinely come and go through mobility, drained batteries, failures, and lost connectivity. Here every device is under attack, new devices join, and others leave, all at once. Watch the swarm absorb it, security scores collapse where devices are hit, the roles re-elect onto the healthiest devices, and the game reruns every round. The federated learning keeps training locally, on the devices at the edge, with no cloud, through the chaos. Fourth, it builds a big computer right at the end user, instead of the distant cloud, pooling nearby devices into one powerful machine at the point of need. That cuts the round-trip delay to a faraway cloud, and keeps private data local, so it never leaves the edge. It targets real edge applications. In healthcare, hospitals jointly train a diagnostic model while patient data never leaves the hospital. Drone fleets keep flying with onboard consensus as drones join and leave. Connected car fleets run in-vehicle intrusion detection and cooperative learning. And factory floor robots share models and run real-time safety checks, with no cloud round trip. Fifth, it runs several kinds of federated learning together, distributed, heterogeneous with, and split learning, concurrently, and it runs them alongside a full cybersecurity stack, intrusion detection, forecasting and mitigation, plus eBPF kernel-level protection on every device. A closer look at the federated learning, where the raw data never leaves the device, only model updates are shared. In distributed FL, every device trains the same model on its own private data, and the aggregator averages the weights, that is Fed average. In heterogeneous FL, each device trains a different sized model matched to its capability, full, light or tiny, and the aggregator averages the shared parts. And split learning cuts one model across a client and a helper device, exchanging only the activations at the cut. All three run at once on the same swarm. Here are the services embedded in the system, and every one runs on real data. On the AI side, distributed federated learning on real MNIST images, heterogeneous width learning, split learning, and YOLO object detection on real camera images. On the security side, the robust 6G detect, forecast and mitigate chain on real network flow data, the Tetragon kernel monitor, and real container telemetry. And here is the live service repository. Scrolling through it, you can see every service currently included, each one real, from federated learning to the security chain. Two more things make this a real platform. First, identity. Every device holds its own decentralized identifier, a DID, and Keycloak turns it into a signed JWT over standard OIDC, while verifiable credentials and a trusted issuer list decide who may join. Second, choice. From the laptop entry point, the end user picks exactly which services to run and can activate or stop any of them on demand, so the same swarm fits any use case, a clinic, a drone fleet, or a factory line. And it holds up under fire. When we attack the devices, the security services detect each attack, name the threat, and keep the kernel protected, while the federated learning keeps training right through. Sixth, the whole architecture is built exactly on the ETSI-NGSILD standard, and it is federated at its core. Every device runs its own NGSILD broker, and every device, every service, and every decision is a standard context entity that federates across the per-device broker mesh, discovered through the context source registry. There is no single point of truth, the swarm state lives, federated, across the devices. That gives interoperability, vendor neutrality, and real confidence for adoption. Here is the architecture, in two views. First, the decentralist design. The laptop is only the entry point and runs no swarm role. The device swarm governs itself, the leader, replica, aggregator, and worker roles are elected among the devices, and the control state feed rates across the per-device NGSILD brokers, so the system keeps running even if the laptop is switched off. And second, the block interaction view, based on the ETSI-NGSILD model principles. It shows every software block on a device, the node context blocks in blue and the swarm context blocks in orange, and the exact messages they exchange through the broker, the game agent, the workload orchestrator, the resource and data managers, the model store and the security blocks. A full wiring reference, down to every port, is in the deliverable. And this is the real Docker desktop, the whole system running as containers on a single laptop, live, all on open source Docker and Kubernetes. You can see every container, the Kubernetes nodes that are the control plane and the devices, the load balancer that is the single entry point, the local image registry, and the relay to the GPU trainer. The CPU and memory columns update in real time as the game and the learning run. In summary, Continuums of CoGNETs is autonomous, lightweight, robust and standards-based, game theoretic autonomy light enough for any end-user device, a resilient IoT-to-cloud computer that survives churn, and distributed AI running with cybersecurity, all on the ETSI-NGSILD standard. It is at Technology Readiness Level 5, validated in a relevant environment, and it brings the cloud to where the data is. Thank you. Continuums of CoGNETs is built by a consortium of 21 partners across Europe and Japan, funded by the European Union and the Swiss Confederation. Learn more at cognets.eu.